Yeah, so you don't, I know you can leave now.
Here we go.
Make that serious.
No, never make it simple.
Maybe come up with more names for you. So I have. No.
Theoretically,
What are you doing?
have 0 point, but
I think I did.
Well, we deal with actual numbers. We don't, that's why we don't.
it's not a
It's just a funny thing. Oh, on your water bottle?
I understand
No, it's even
theoretically.
worse now. It's just
It does
very
not.
bad. Yeah. Dude, this chick, you know the chick was that was really that had the fat guy?
It's a person.
Which one?
The person. No, because she kept yelling at me. So it doesn't count as a person.
Alright.
She kept being like, why doesn't your mom hit you?
No.
Yeah, she kept being like, why doesn't your mom hit you? That's why we're having Tommy goes up like, my mom doesn't hit me because she's my mom, dude. Like, what?
She's not an issue.
She's like, those are like my keys? I always have that on my keys. Are you stupid?
You give this to stretch.
They're
I like mine.
AirTags.
Hey, Maggie.
What?
Yeah.
Go team.
Yeah. We should introduce you to a guy named Jaden.
Alright, guys.
I don't think he should be allowed to come to
Back at it. We are continuing now, getting point number 4 coordinate. So, same formula, same setup. We're gonna now go from 2 to 3, now to 3 to 4, or 4 to 1, should I say, or 3 to 4. Sorry. 3 to 4. So again,
Oh my gosh.
the latitude here, the lat.
6.
So going back to our field notes, right? The distance from 3 to 4 is at 1,029.34. Scroll right here, right? We're at 0.3. We backsighted 2. We foresighted. We got that slope distance of 1,029.34. So again, you just take that distance there. Again, the latitude is times the cosine of the azimuth. And we have the azimuth that we calculated is 19 degrees, 7 minutes, 58 seconds. That gives us 972.481. Now, if we go down and calculate the departure from 3 to 4. It is, again, the slope distance times this time the sine. Give us 337.375. So now to apply it to the coordinates, right? We need to apply it to this point that we're sitting at, right? We're here, our total station's here. We need to apply the coordinates for this spot. So if we go to do the 4 there. So again, if we coming off our coordinates from point 3, we go our northern. It's going to be equal to, again, the coordinate or the northern of 3988.32. And it's going to be 2 added to that lat, 972. We get northern of 0.4, 960 0.513. Okay. Again, that is the 4. Now if we do the easting, again, it's this coordinate here that we're using. It's 3822.138. Plus the departure, right? Of 4. It's going to be 4159.558. Yeah, that's 37. It's this portion here, right? So now we're closing back in, right? We started with 1, we gave it 5,000, 5,000. We had 2 unadjusted coordinates, we got 3 unadjusted coordinates, we just calculated 4 unadjusted coordinates. Now we're coming back to 5, or back to 1 to see what our closure is between 5,000 and what we're calculating right now. Right? So again, solving for the 0.4 or 0.1 coordinates. Again, they've unadjusted. There you go, the lap from this time 4 to 1 equal again to the distance that we see here in our field notes. It's not written here on the sketch, but if you come up down here, you scroll down, you see it here. When you're at 0.4, backside 3, going to 1, right, you get 841.31 for the slope distance. So that is the distance or the slope distance that we were using. You're going to times that cosine of our azimuth, and that azimuth was 87, 18. Eight. Departure. 1. Sine of the azimuth. Get 840.385. Okay, go there. All right. So now let's see what our closing coordinates are back on 1. All right. So again, if we do the northerly of 1, it's going to be equal to the previous established coordinates here. We're going to go first the northern. It's going to be 4960.513 plus our latitude. It's going to be 39.48. That's going to be 4,999.961. Okay. Again, closing, right? Easting. 1. gonna be 4,159.58 plus our departure, 840.385. That's gonna be 4,000. Again, we're close, right? Pretty dang close for our calculations when we ran through the whole thing. But now, in order, because we are surveyors and we are licensed professionals, we have to make this right, and we have to adjust the coordinates. And we have to make sure that we close mathematically with our geometry, okay? So one, we need to calculate, we need to go back, and I didn't pull it up, but on the notes, right, step number 7 would be, I pulled it up here. I gave you guys on that homework. Where the heck it is? 4. We look at it, and we look at the notes here. We say, all right, we calculated the unadjusted coordinates for each station. Now we need to calculate the area of closure for the traverse, right? So we're gonna calculate the length of the traverse perimeter, calculate the linear error, calculate the relative error, and then determine if the results meet the requirement of the project specifications. So this probably 7 and 8. I mean, you see what we just went through, you go, man, that was pretty long. Here we go into the nitty gritty, okay? So we have to adjust, right? We have to get it right. So we're gonna step over to step 7. So step 7 is calculate the area of closure for the traverse. So again, the A part, pretty simple. We need to calculate the length of the traverse perimeter. Someone's got a calculator, they can do it for me real quick. Again, all we're gonna do is just add up those portions, right? So let me go back here. Let's go back to those field notes. All we're doing is taking, right, all we just gotta add is these slope distances together to figure that out. So if we take those slope distances, take the sum of them. What do we get?
Green 959.51.
3,959.51. Right? There's our length of traverse perimeter, right? So B is now calculate the linear error closure. All right. Formula, the linear error closure. Linear, oh, sorry. Rewrite that. Equal to the square root of our delta northings, what we started and closed on, squared, plus the delta V, again, what we started and closed on. All right. So what was our starting northing? 5,000. Somebody remember what the clothing was?
1,999.961.
Perfect. So again, we're just gonna go to the hundredth on this one. Just go, right. Again, starting for Easting was 5,000, and the closing for Easting, 4,999. You guys, any?
0.069. Get this right.
Just round it up.
Oh, yeah, 0.0691.
Just, again, going to 100. 700ths of a foot, right? That is your linear error closure. 700ths of a foot. All right, moving on. We now calculate the relative error closure. And that's just going to be your linear error closure over the traverse perimeter. That ratio is approximately, in a ratio format, 1/56. So what does that mean? That means that when you close on your perimeter, because of the traverse or the site distance, your ratio is 1 in 56 thousandths, right? The Oregon's revised statutes is 1 in 10 thousandths. So you're pretty good, right? You're pretty decent, but that's for boundary. That's for like, subdivisions here and there. You're within half an inch, great. But let's say you're working in a construction field where the specs are within 1/8 of an inch. So you need to make sure that you button that down so that your relative error is adjusted through the whole thing, for your coordinates, for your angles, for your distances, right? We have to get those things correct. Let's ask the question, does it meet, right? Does it meet the standard? Survey. Closure mesh standards. Does it meet the survey closure standards? Well, again, going back to the federal geodetic standards, we have part 4. We have, again, ranking systems. Let's just say we're at third order, right? We go back, I mean, I can go show you the whole entire list, but it's too boring. So let's just say the minimum ratio to 1 in 50,000, or 1 in 5,000, should I say? Right? So again, let's say you are working with class 2, right? So being that you guys close in 1 in 56,000, you're good to go, right? Ratio wise. The other part that you can show or understand whether it makes sense of this, the formula there for the angular closure of this class, or this order, is 20 seconds times the square root of angle stations, okay? So again, n, the number of angle stations. Well, looking at the sketch, how many angles did you have? Right? Just when you set up and turned. You had 4, right? So this would equal 20 seconds times the square root of 4. You would be down to, or you would be 40 seconds. Right. That would be your angle misclosure. Or angle closure. What did we get? Do you guys remember? Right off the bat, that was like the second thing we did. When we added the whole thing up, we added to 360. What was the delta? There you go. You got 4 seconds, right? Pretty good. All right. So for us, all right, our angular closure 4 seconds. So we check, right? We're good. We're there. We know we meet order 3, class 2 with the ratio. Right? Now we just need to calculate adjusted coordinates. First thing we got to do, again, going back, next step here is step 8. Apply the compass rule to unadjusted coordinates to create adjusted coordinates. This is pretty blurry, but I'll write down the formula so you guys can see it. but it's the closure departure, and it's equal to the negative closure in departure over the length of traverse times the length of that certain line, right? So how do we determine the closure and departure? Everybody have a guess? It's just all the sum of all the departures and the sum of all the lats. So again, we can write that here in a second. So again, step 8. That is compass rule. Calculate adjustments to latitude and departure. So again, both formulas here, I'll write them down. Closure and latitude is equal to negative closure and latitude over the length of traverse. That's going to be times the length of the line. So if I gave you guys the closure and departure, what's just that going to be? Same thing, it's just closure. Yeah, same thing, it's just closure and departure, right? Over the traverse. The length of line. Oh, that's right. Makes you hope that you have a software to just do this for you and plug it all in.
I'm assuming there is, but you're just messing with it.
Well, there is, but here's the thing: is you got to learn how to walk and crawl before you run. So
Oh.
you can't just leave you guys in tools and be like, "Go ahead, go start doing it." And then you become just any old contractor that doesn't know how to work the actual system. You go point to the survey and go, "Hey, how do you do this?" And so, well, I had 4 years of traverse adjustments and I could figure it out, but you're gonna have to pay me a pretty penny for it. All right, so how do you think we come up with the closure and latitude, Nick?
You got me.
You plug in.
We go back to,
With the sum of them.
and we sum up, right? The latitudes, right? Here, here.
Did we already do this?
No, we did not do that. Here and here, right? So we take these values, right? And we take the sum of them as they are, negative, positive, positive, positive.
That's 4 numbers, dude.
That's 4 numbers. That's 4 numbers to go.
Expect from us?
So that means down here, I'll put it on the side note. The closure of latitude is negative 0.38. If we do the same thing for the closure and departure. Right, take the summation of all our departures. You get negative 0.0057. There. Does everybody understand that? That where those numbers come from? Just the summations, right? Summations of the last, summations of the departures. That's how we got those two numbers. Because pretty soon we're going to be plugging those up here into this formula, right? So it's not going to change, right? When we go from 1 to 2, 2 to 3, 3 to 4, 4 to 1, it's always going to be your closure and lat is going to be that 0.038. The closure depart, negative 0.038. And the closure departure is going to be negative 0.057, right? So again, start working those for let's start doing the corrections for line 1. Line 1 to 2. Again, using our formula that we just broke down. Negative 38 over our traverse perimeter at 3,959.51 times what is our length of line for 1 to 2? Right there, 1,000, or slope distance, should I say? 1,024.78. We get, on the other foot, 0.01. Now the departure for that same line. Again, it's that negative 0.057 over our traverse perimeter times, again, length of line. Point 0.015, 15 thousandths. Next line, 2 to 3. So again, does the length of the line change? Yeah, because now we're going from 2 to 3. So we're going from, so now our slope distance or our length of line is 1,064.08, right? So that's what we have to change here. That's what's pretty much changing for every single one of these, is that length of line.
So it's still negative.
Yeah, sorry. Yep, okay. It is still negative. Yeah. 100 foot. I'll just write down the departure here for 2 and 3. You get the same result as our previous departure of 15,000 total. All right. Halfway there, guys. Halfway there.
Four more.
Wait, shouldn't the departure be 0.057
So yeah, I should be
0.57?
Well, to the left.
instead of negative 0.038?
Where you
Right,
at?
I go up.
Oh, yeah. Oh, I'm sorry. Yeah. Good job. Again. Oh. At least I know you guys aren't sleeping. It's the positive. As much torture as it is, you're not falling asleep.
Yeah, well, the
I
bell
never
hasn't
fall
rung
asleep in
yet.
front of you.
It's okay.
Is
I'll
this?
take it. I'll take it again. So again, now we have the latitude to conquer on 3 to 4. Now, we're going to the different slope distance, right? It's going to be that 1,029.34. Makes it again. Same result. Work the departure. Since we're length of line. We get again. 15,000. And then the final correction for this length of line. And then our final distance is not written up here on the sketch, but it is in the notes. Final length. That 841.3. And that just a little different. That's just 8,000. This is going to give us 12,000. Or yeah, 12,000. So a good check, make sure that you actually did it correctly. Again, what was our closure for latitude? It's positive or negative? Negative, right? So again, our closure was at, let me see how to write this. Closure in lab is, right, negative 0.038, okay? What's the summation of our lat corrections if we take them right here, right? So we add up those four numbers in the latitude department, 8,000, 100, 100, 100. What are we gonna get?
0.038.
0.038 positive, right?
Yeah.
So that just becomes 0, right? And we take the 2, that becomes positive 0.03, right? So this means you get 0. So that means that we did our formula correctly, we went through the process, and we know that this adjustment is going to be 0, right? So that means if we apply this correction to these latitude corrections to our coordinates, to our north and east, it should adjust everything to close back to 5,000, 5,000. That makes sense? So again, closure and departure, negative 0.57. And the summation, right, of the departure corrections is positive 5%. Again, we'll get 0, 0 for both. The last piece of this, or actually, sorry, yeah, last piece is calculate the adjusted coordinates, right? And how are we going to calculate those adjusted coordinates? Using our correction latitude and departures, right? Again, step 9. Calculate adjusted coordinates. So again, the way to do that is we take our, hang on. We take our, for our first point, okay, we're going to take this, again, this value here, add it or subtract it to that coordinate like we did, right, to that 5,000, 5,000, and then apply our adjusted latitude, right? So it's going to look, zoom out again, go down, it'll look like this. So adjusted coordinates, for point 2 is again northern here. I'm just going to put northern 2 equal to that 5,000, right? minus that first latitude that we calculated, negative 1,018.446, plus that first departure, or latitude, or sorry, not departure, that first correction in latitude, which is at 0.01. That means that the northing 2 is going to be now 3,981.56. Right down there. And our easting for 0.2. We get that 5,000 minus that departure value, which was negative 113.575, plus that first correction departure, 0.015, and we get the value of 4,886.26. Right. So that is the adjusted coordinates for 0.2 now.
Why are we not starting at 1?
Because one is already set up 1,000.
We have to close that line.
Oh.
We're going to close that line. We started at 5,000, 5,000, right?
Fair.
And we're coming back. We should have 5,000, 5,000 when we end.
Give you a question?
No, no.
I'll ask you a question. Why would you ask a question?
All right. So adjusted coordinates. Point 3 is again the northing of 3 is equal to our now new northerly 2 adjusted coordinates. So that's that 3,981.56. Plus again, the result of that that latitude that we already solved for, which was 6.479, plus our closure departure, or adjusted latitude. That's going to be the northern of 3 coordinate adjusted here is going to be 3,988.05. Three, again, we're going to use that 4,886.2326. Subtracted by our departure of that line. Now, right in here, and that's 3,822.21.
Are you missing the 8 there? Or 6, actually.
Oh, I know. Thank you.
Credit?
Extra credit.
Yes. Thanks.
Now for 4, we're going to have the northern of 4 is going to be to again the new value there of 3,988.05 plus our latitude result plus the correction on latitude. That is 4,960.54. Easton of 4.
Yeah, so just.
Again, 3,822.21 plus the departure result that we had previously, plus our departure correction. $4,159.6.
Where are you getting the results?
So
What step?
that's step number. Go back to step number 6. Yeah, step number 6.
Oh, that's where the middle number comes from?
Yep. Step number 6. So now to close it, closing back on 1. At the northern of 1, we have our adjusted coordinates there that we're coming back off of. Again, we have our departure from step 6. Or sorry, latitude from step 6. Plus our correction in latitude of 8 thousandths. Northern of 1. 5,000. Easton of 1. Plus our departure. Plus our correction. One, 2. 5,000. I know what you're thinking. That was awesome. Let's do it again. For our vanity, let's not. Okay.
So
Put this on the final. I'm just leaving.
Yeah, did your homework.
Yeah?
No, not really. I did
Why did you
example.
play with my
Oh
English?
my
I
god.
did example for your homework.
That's seriously what I have to do.
So you have to do.
The name is a heartbreaker. So it's probably like the lead singer.
You know what else though? Excel.
What? Excel?
Excel.
What?
Why is Excel the
Why
answer
did
to
you teach us on
everything,
Excel?
dude?
I'm bad at Excel.
Because you gotta do it by hand.
I love
Understand how to plug it into Excel.
It all goes back to freaking Excel. Like, I'm not even joking at that point, dude.
Right, it all circles back to drinking.
And Excel, dude. It's always one of those two.
We get it whenever someone calls.
I'm in Excel's useful.
The trick's not useful.
Oh, it's more useful. It's just for calculating some CSAT.
We already have the internal angles, right?
Yeah. So that was so we did the average on that jump. So when we subtracted that, that's how we calculated our material.
Okay. But on our assignment, it's already given, right?
Oh yeah, that's it right there. Those are,
And then we already have horizontal distances, not slope distances.
yeah. So yeah, it's already calculated for you. Yep.
So step 4 is not
Not
necessary.
Yeah.
Okay.
It's not necessary at all.
Okay, cool. I'm also not going to be here Friday.
Okay.
I'm going to be at an NCES meeting.
All right.
Can I just watch the video?
Yeah, of course.
Dude,
As I say, otherwise I can cancel class for you.